Hello and welcome to Chapter 6 on flooding. So my plan for this is to have a little video for each of the sections in the chapter and then do a little quiz at the end. That way you can break up your learning and not be overwhelmed with everything. Also, I won't be overwhelmed with creating all the content. So let's get into flooding. We're going to cover 6.1, which is basically all the information that you need to know about rivers. So here are the learning objectives. And for this video here, I think we're only going to cover learning objective 1, which is explain basic river processes. But to show you what's coming up in the future, we're going to compare and contrast different flooding, like flash floods and downstream floods, and then mega floods, and know why the differences are important. We're going to summarize the regions that are at risk from flooding and the global impact of flooding. We are in a region that is at risk for flooding. We're going to differentiate between the effects of flooding and the linkages with other hazards. We're going to describe the benefits of periodic flooding, discuss how human activity can significantly affect river processes and flooding. So what do humans do to make it worse? We're going to summarize why being proactive with flood hazards is in the long term more significant in reducing the flood hazard than being reactive to a flood. So knowing where your floods could happen and being proactive at first is actually a better plan. Evaluate the adjustments we can make to minimize flood deaths and damage, and to summarize how people perceive flooding. So as I said, we're going to talk about 6.1, an introduction to rivers. So here we have a picture of a lady who got obviously flooded out of her house and is being rescued. Here is a picture of looks like a neighborhood and some other areas that have experienced flooding. And here's flooding in a downtown area, and this looks like it could be maybe India or Bangladesh that has been flooded. All right, so to understand why things flood, we first have to understand rivers and how they develop and how they eventually flood. So this is going to be all the information about how a river develops. So all rivers are unique, but there are some things that we can understand about rivers that will help understand how flooding occurs. So one of the geologic cycles that we've discussed in the class so far is the hydrologic cycle. We talked about the tectonic cycle, we talked about the rock cycle, but the hydrologic cycle, basically streams and rivers, are part of the water cycle that we have on this planet. So the hydrologic cycle basically is water evaporating from the surface, mostly the ocean. It's collecting in the atmosphere, then precipitating back to the surface. It returns to the oceans then by flowing underground and across the surface. So it's across the surface that we are going to discuss today. So next, the anatomy of a river. So here's just some terms that we have to discuss rivers. So runoff is surface drainage, and then that runoff finds its way to a small stream. So if you think about any of the ground that you have out there, if it's raining, you're going to have some water that's absorbed into the soil and then some water that will just run off. And it's the runoff that goes into streams and rivers. So small streams will then merge as tributaries to form larger streams or rivers. So streams and rivers, the terminology that we use, they only really differ in the size. So streams are generally thought to be small rivers. Streams can also be called a creek or a brook or a river, depending on where you live, but geologists commonly call any body of water that flows in a channel a stream. So it's runoff if it's sort of running across the dirt or the ground, and if it actually is flowing in a channel that's cut, then it's called a stream. So continuing on with rivers, a region that is drained by a single river or stream is called a drainage basin, or you can call it a watershed or a river basin or a catchment. So each stream has its own river basin, and large river basins are made up of hundreds of smaller drainage basins, which we'll have a picture on that in a second. So the gradient is a characteristic of a river that describes kind of the slope over the land over which it flows. So it's kind of the vertical drop over the horizontal distance that the river will flow, just like in math class. If you remember your slope from your introduction to algebra class or your intermediate algebra class, yeah, you thought you'd never going to use any of that, but look, there it is right there. It's right there on that slide. Ha. Anyway, okay. So here is a picture of a drainage basin. All right, so here's the boundary of the drainage basin. So all of the water, all of the rain that falls everywhere in this area is going to flow into one of these little streams, join a tributary, and then eventually flow down to the ocean. So these streams will flow into a river and to the ocean. If you notice, we have point A up here, up in the mountains, and we have point B down here in the coastal plain. So this is high up in elevation and low in elevation. Any rain that falls over here will be part of a different drainage boundary or a different drainage basin. So here's our point A and our point B from the other slide, and it sort of shows you the elevation. So we started up in the mountains up here, and then we flow over this distance down to the plains where we eventually get to the ocean. So this is, even though it's curved, this is kind of the slope that we talked about, or the gradient of the river. We have a couple other terms, and we can discuss how the river valleys are slightly different. So headwaters are when we are near the top of the river. So it's very high in elevation, and then the distance across the valley is kind of right here, and the river channel is like that. So it sort of forms a V-shaped river valley. This is where this is headwaters, so that's where things get started. So rain falls and it flows and it creates a river like that. Then at the base level, which is the lowest elevation, we don't have a river valley at this point exactly. We have what's called a floodplain, and the river will flow in here, and then this is the floodplain, and it's just above sea level here. So one of the things that rivers do is they move water, but they also transport earth materials. So there are visible and invisible material that are transported by the river. So the quantity of the material that's moved is called the total load, and which is then broken down into these three sections. So we have a bed load, a suspended load, and a dissolved load. The bed load is the sand and gravel particles that roll, slide, and bounce along the channel bottom of the rapidly moving water. It makes up less than 10% of the total load. So if you were to have a camera under the Mississippi and you're looking at the bottom of the river, you would see sand and gravel particles that are sort of moving along with the water. You have this thing called the suspended load, which is the small silt and clay particles that are carried above the stream bed by flowing water, and it's nearly 90% of the total load is the suspended load. That's when you look at the Mississippi and it's brown and muddy. That's the small silt and clay particles that are being carried by the water. And then you have the dissolved load, which is basically ions. It's carried in a chemical solution from weathering rocks. So any materials that is basically broken down into the atoms or molecules that is just flowing along, it's dissolved into the water that's flowing in the river. So we have at the end of the river this thing called an alluvial fan. This is one in Death Valley. We actually, they kind of call the area around here an alluvial plain. Mississippi, anyway, we'll get to that in a second. But so when streams flow, they will expand when they get to the bottom part of the riverbed where it's flowing, right? Oh, my brain just stopped there for a second. So it slowed down as the river goes from the mountains to the plains, or to the channel into the ocean, lake or pond, of course. So it sort of slows down and spreads out when it gets into sort of flat areas. So it's traveling in the mountains, it's moving fast because it's running down hills and stuff. But when it's kind of traveling along flat plains, it will slow down. So rivers commonly form these alluvial fans at locations where it's slowing down. They can be triangular or irregularly shaped, and they deposit their water there. So it's called a delta if it extends out into a body of water. So yeah, when the suspended load and the bed load when the water slows down, all those things kind of fall out of the flow, and so that's where these deposits come from. All right, so this is a picture of the Mississippi Delta. So just this Mississippi River comes down and deposits all this material as it's flowing into the ocean. So if you were to take a helicopter and ride above a river, you would see some physical characteristics of the river. So rivers and floodplains result from the interaction of flowing water and moving sediment. So those are the things that make the rivers what they are. So we have two different channel patterns that you could see if you were in your helicopter. You'd have a meandering pattern or a braided pattern. Meandering is a single thread channel similar to the curves of a moving snake, which we'll see pictures of that in a second. And then a braided pattern is a multi-thread channel where two or more channels will divide and unite and flow. The river will flow that way. We'll have a picture of that in a second too. The floodplain is a relatively flat land that's adjacent to a river that is produced by these different river processes, which we're going to talk about in a second. And even though these have been studied for over a century, and the book even says Einstein even tried to figure it out, no one exactly knows why rivers will meander, which we'll talk about that in a second. So here's the floodplain that we talked about. And then here we have a river deposit, and here are some of the floodplain deposits, which we're going to talk about how this is all. Here's another picture with a river channel, and here's the floodplain. And if you notice, this is a braided pattern if we were flying in our little helicopter over here. And the reason why we know that is because there's all these multi-channels here. So it's not just one meandering river, it's a braided river pattern. So some characteristics of a meandering river. So it will like the river will flow straight, right? And then it will start to meander. And we're going to learn why. Well, not why, because nobody's figured that out, but we'll learn how in just a second. So water moves faster on these outside portions around the curve. Around the meander bend is what they call it. And faster moving water will then erode the riverbank on the outside bend, and it will form steep or near vertical slope, which is called a cut bank. We have a picture of that in a second. Slower water on the inside, it will move slower. Slower water on the inside of the meander bend will deposit the sand and sometimes gravel to form this thing called a point bar. Because as I said before, when the water starts to slow down, the suspended load and the bed load will sort of precipitate out. They'll fall to the ground. So this continuous erosion and deposition causes the meander to move laterally in a different direction. So this one will move this way laterally, and that one will move that way laterally. This creates the floodplain that we have in oxbow lakes. We'll have pictures in just a second. So the river's coming down, it starts to meander, it cuts into here and creates a cut bank, which this water's moving faster. This water on the inside of the curve is moving slower, and it will deposit the gravel and sand there. When it comes around, there's this little riffle here, which is kind of a rough area in the water, and I'm not going to test you on that, but here's once again cut bank and the pools that's created, and then the point bars that are created, and comes down. So what happens is this river used to flow over here, but then it's sort of like left all this behind, and that's what leaves the lake behind. And you can also see different areas here. They're called meander scrolls, where some of these point bars have now been pushed back. This used to be a point bar, and it's moved since then. So here's a meander bend, and here's an oxbow lake that you can see. It's got this characteristic horseshoe kind of look to it. And once again, here's a point bar, and then here's cut bank over here, cut bank. If you've ever been floating, you've seen this many, many times. Okay, so river systems have three different zones. So a drainage basin with sediment and water will make up a river system that consists of three different zones. The they each have different characteristics. So we talk zone 1, which is the zone of production. This is where water and sediment is produced, basically up in the mountains. It's the upper part of the river. There's a big steep slope and there's more precipitation. The water moves faster. It creates V-shaped valleys with waterfalls and rapids. Zone 2 is the zone of transport. Water moves more laterally in a meandering pattern. That is where we live in the Mississippi River. So this is more up in the mountains. This is where it's just, the river's just flowing. And then zone 3 is the zone of deposition, where water velocity slows near the base level, and the sediment is then deposited, creating an alluvial fan or a delta. So here we have zone 1, zone 2, and zone 3. So zone 1 up here in the mountains, the rain falls down and the runoff starts to flow and create streams. Here you can have flash flooding up in the mountains up here. You can also have a landslide. Then the river kind of flows down to get to the zone of transport, where we have water and sediment that was produced up here is now flowing, and we have our meandering or braiding pattern. We also have a floodplain, which is generally flat, and we also have our cut banks and our deposits, sandbars. What are they called? It was on the last slide. Oh my gosh. Anyway, you see it here. And then finally, zone 3, zone of deposition, where the sediment, the water, I'm sorry, I'm laughing at myself. Not very professional. The water slows down enough that the suspended load and the bed load precipitate out of the water, and then they're deposited. Very good. Very good. Got through it. All right. So here's the river channel and a floodplain that is created. So this is material that's all been brought down. It's not all been brought down, but you know what I'm saying. It's brought down and deposited here. All right, so this is the end of section 6.1. I'm sure you're very happy. Like I said, there's going to be a short quiz after this just to help reinforce the information that you've learned here in this section. So here is learning objective 1, explain basic river processes. Streams and rivers form a basic transport system of the rock cycle and are a primary erosion agent in shaping the landscape. So water erodes, that's just what it does. It also flows. The region drained by a stream system is called the drainage basin or watershed. Rivers carry chemicals in their dissolved load and sediment in their suspended loads and bed loads. Discharge refers to the volume of water moving past a particular location in a river per unit time. I didn't talk about that because I'm not going to test you on it, but that's just basically what they do to calculate how much water is moving in a river or stream. Sediment deposited by lateral migration of meanders in a stream and by the periodic overflow of the stream create the floodplain. The configuration of a stream channel as seen in an aerial view is called the channel pattern, and the patterns can be braided or meandering, or both may appear in the same river. So that is it for section 6.1. 6.2 will be loaded soon, and please go finish your quiz. If you have any questions, comments, or concerns, please email me. Anyway, the reason why I'm doing it this way is because you can read the book. You should be learning a couple of different ways. You should read the book always, of course. Then we have our charts. And then the reason why I'm doing this voiceover is because some people learn by reading and some people learn by hearing. So if you just want to read the charts and then take the quiz, I'm okay with that too, but you might be a person who needs to listen, and that's fine. Also, if you need to listen to me at faster speeds, for your own sanity, then I respect that as well. So anyway, if you have any questions, please email me and I'll talk to you soon.